Welcome to C++tutor.com. This is a production of YouTube channel Learnorama and the Facebook page Awesome C Programming Tutorials in High Def. In this tutorial we are going to talk about some examples of data structures. In the previous tutorial we learned what data structures are and what abstract data types are. In this tutorial we are going to talk about some example data structures. If you haven't watched the previous tutorial, you should actually watch that tutorial first, so that you know what a data structure is and what an abstract data type is. Okay, so the examples of data structures. Essentially, actually, even something even a data type as simple as an integer is actually an abstract data type. Because if you think about it, I mean, an integer is an integer. It has a mathematical definition, and it has operations defined on it, like addition and subtraction and stuff like that. So an integer is definitely an abstract data type. An integer, when it is represented as 4 bytes, for example, we carve out 4 bytes in the memory, and we store the integer as bits, that makes it a data structure. This is, now we are talking about the representation of integer, the storage and organization of an integer, so that makes it a data structure. And then there are algorithms to add two integers together, right? That you take this byte and add this byte, and then there is a carry, and then you add another byte, and so on. So there are algorithms to add, subtract, multiply, divide integers. So it definitely satisfies the condition. The thing is that it's so trivial that we don't consider integer as data structure. We don't talk about it as a data structure because it's so simple and trivial. I guess the smallest or the simplest form of data structure that that is not too simple and not it's that we can actually start considering a data structure is an array. An array essentially is a data structure because we are saying that an array is gonna be a collection of elements, right, stored in memory what should I say, in like consecutive bytes, right? In the consecutive memory. It's not like one element is stored in one part of the memory and the other element is stored in the other part of the memory. No, it's like all the elements are consecutively stored in the memory. So in a sequence, right, one after the other, back to back. So this, we are talking about the representation. Actually, essentially, what array is doing is trying to trying to implement a list of something, right? That's what it's trying to do, the ADT list, right? So array is definitely a data structure. What else is a data structure? Something called linked list. Linked list, again, as the name suggests, it's a representation of a list. A particular way of storing the elements of a list, that's what a linked list is. So a linked list is definitely a data structure. Okay, and we will talk about linked list in the subsequent tutorials in a pretty good detail, actually. But just as an introduction, what linked list is, it's in array, all the elements, one of the features of properties of array is that all the elements in an array are consecutive in memory. They are back to back in memory. In linked list, that's not the case. Every element called a node is actually can be located anywhere in the memory. Okay, so if this is an element and then this has an element, they are not consecutive in the memory. They are not back to back in the memory. And then this is an element. These could be integers. If these are integers, this could be integer. If we are talking about a list of integers, then these are integers. If we are talking about a list of I don't know, strings, list of names, then these are, each one of them is a string, and they are names, and so on. And how they are related or linked together, using pointers. So we start with one pointer and make it point to the first element, and then the first element at the end has a next pointer, and we make that point to the next element, and then this one has the next pointer and it points to the next element, and so on until we reach the last element, whose next pointer is pointing to nothing. It's a null pointer. If you remember what pointers are, you would understand what I'm talking about. And if you don't know what pointers are, you need to go back and watch the tutorials on pointers. There are quite a few tutorials that I made, so you could go and look them up. So that's the linked list. It's a data structure. It's a way of storing a list. So it satisfies the definition of data structures, and there are operations defined on it. For example, how to insert an element in the middle of a list. Okay, like somewhere here. If you want to store it, how do you do that? Okay, how to traverse through the list, how to sort this list, and so on. And then there are different variations of linked lists also. So we are not going to talk about those. Then what we have is well, we will talk about them in the subsequent tutorials. We are not going to talk about them in this tutorial. The next is a tree, for example. A tree is a very interesting data structure. It's a little bit more complicated than linked list, but it's an awesome data structure. A lot of time, you have data in a tree structure, right? So you have a node, and then there are other nodes which are somehow linked to this node, and then each one of them may have other nodes which are linked together, and then another node, and then another node, and then these may have other nodes, and so on. Okay, so this if your data is organized like this, then you have a tree structure. You need, in order to represent your data, you need trees. You need the tree data structure. For example, the directory structure. There are directories, and then inside the directories there are files, right? And some of them are directories, so inside them there are files, and some of them are directories, so inside them there could be files. So you see that the directory structure is an excellent example of a tree structure, and to some extent, for example, your generation tree is also a tree. That's why it's called tree, right? It's kind of one of the properties of tree here. Tree data structure is that every node has one and only one parent. So this is the parent of these four nodes. Okay, and this is the parent of these three nodes, and so on, except for the root node, which does not have any parent, and that's the start of the tree, the root of the tree. Okay, it doesn't look like tree unless you turn it around. If you turn this whole thing around, then it will look like a tree, right? So with this thing as the root, and with all these as the branches and stuff, and sure enough, that's why it's called root, and these are called branches, and the end points are just like in a tree. The nodes which don't have any children, those nodes are called leaves, just like the leaves in a tree. Anyway, and then we have something called graph. It's even more complicated than trees. Graph is again, it has nodes, but then all these nodes are connected together with no restrictions as such in general, right? Like here there were restrictions. What were the restrictions? That every node has a parent, and only one parent, except the root node, which doesn't have any parent. So you cannot have a relationship like this. Okay, that's not a tree anymore, because this node has two parents. So it's not a tree anymore. What is it? It's a graph now. Now this is a graph. In graph, any node could be linked to any number of other nodes, and that's what makes it into a graph. So because there are more paths available, it makes it more complex. And really it's not more complex, but it's a different data structure, I should say that. This is tree and this is data, this is graph. It's relatively hard to implement this as opposed to this, but that's all it is. So this is called graph. And graphs can have different kind of there can be different kind of graphs. For example, cyclic graph, for example, directed graph. Directed graphs are the ones where there is not only that the nodes are linked, but there is some kind of relationship going from one node to another. For example, this could be dependency. This node depends upon this node. Okay, and similarly, this node depends upon this node, and so on. Okay, so some kind of relationship, that this node comes first and then this node comes next. Okay, there is some kind of relationship going on. So there is this the concept of direction here. It's not just linked together, they are directional. So that's called a directional graph. And though if you don't have directions, it's called a directed graph. And then because of the directions, there is a concept of flow, right? So you go from here to here, and then here to here, and then if you go from here to here, then this is a cycle. So it's a cyclic graph. And if you, instead of going from here to here, let's see, if you go from here to here, so you can see there is no cycle here. So it's an acyclic graph, acyclic directed graph, ADG. It's an awesome graph. It's an awesome data structure. It's there are lots of problems around us, lots of data around us which can be represented like this, ADG. So anyway, so these are all different kinds of data structures. So keep watching, and don't forget to visit c++tutor.com and give a thumbs up if you like this tutorial. Thank you so much.